lesson 633, which is titled Making Connections, Systems, Solutions, and Graphs. So we're going to answer the questions. Question, how can a graph show the solution? All right, so question number 101 is called a new elimination challenge. Carefully examine this system. 4x plus 3y equals 10, 9x minus 4y equals 1. With your team, propose a way to combine these equations so that you eventually have one equation with one variable. Be prepared to share your answer with the class. All right, so if we have these two equations, does anybody see a way we could use elimination to combine these? Yes?
We can multiply one of the equations by 4 or 3.
Yeah, okay. So which one would you multiply by 4? The first one. If you multiply the top one by 4 and the bottom one by 3, then your y variables will have opposite coefficients and you'll be able to eliminate. So that's one way. What if we wanted to eliminate the x term? What could we multiply by? 9 times 2? You mean 9 times the first one? Do you mean 9 times the first equation? Yes. And then what would you multiply the second equation by? 4. One of those would need to be what? Negative. One of them, gentlemen, I don't know why you're having a full-on conversation right now. What? Okay, then turn around and pay attention up here. All right, so you're going to have, you could multiply by the first one by 9 and the second one by 4. One of them would be negative. That way you could have opposite coefficients. So you have two choices. You could multiply equation 1 by 4 and equation 2 by 3. Or you could multiply equation 1 by negative 9 and equation 2 by 4. Or there's a couple other options, okay? But these first two are gonna work, okay? Question 102. The art club at school is painting a mural using their school colors. Blue paint comes in a 5-ounce container costing $2 per container. The containers of silver paint holds 2 ounces and costs $3 per container. The art club spent $56 and bought a total of 74 ounces of paint. How many containers of blue paint and how many containers of silver paint did the art club buy? Okay, so we're going to write two equations that represent this scenario. Okay, one of them is going to have to do with what? What kind of symbol do you see in that scenario? Look at the whole problem. See what symbol you see in there. What do you see? A dollar sign. So one of your equations is going to have to do with how much they cost. Okay? The other equation is going to have to do with something else. What do you think it is? How many ounces they are, the blue container of paint and the silver container of paint. Okay, so I'm going to use B for blue and S for silver. And then I'm going to write two equations. The first one I did with money. Okay, so it was $2 for the blue and $3 for the silver for a total of $56. Then I did an equation for how much they weigh. So the blue weighed 5 ounces, the silver weighed 2 ounces, and altogether it weighs 74. Once you have your two equations, you see where you can eliminate. Can't eliminate here, can't eliminate here, so I'm going to need to multiply. So I'm going to take the first equation and multiply everything by -2. Then I'm going to take the second equation and I'm going to multiply everything by +3. That's going to get which variable opposites and which variable eliminated. So I can either eliminate the blue or I can eliminate the silver. Which one is that going to eliminate? The silver, okay? So negative 2 times 2b is negative 4b. Negative 2 times 3s is negative 6s. And negative 2 times 56 is negative 112. Then I multiplied by 3. So 3 times 5b is 15b. 3 times 2s is 6s. And 3 times 74 is 222. My s's will eliminate, and I'm going to combine everything that's left. So negative 4b plus 15b is 11b. And negative 112 plus 222 is 110. So I divide both sides by 11, and that tells me I have 10 blue containers. And I just need to figure out my silver. So I'm going to take that 10 and plug it back in. So I'm going to pick either of the two original equations. It looks like I picked the first one. So I said 2 times 10, which is 20. So I subtract 20 from both sides, and then I divide by 3, which means I'm going to have 12 containers of silver. Okay. All right, question 103 says Tracy's team was given the following system by their teacher. We have 10x plus 4y equals negative 8, and we have 5x plus 2y equals 10. What do they want us to do? They want us to use the elimination method to solve. So I'm going to take that second equation and multiply it by negative 2 so that my y's will eliminate. So negative 2 times 5x is negative 10x, and negative 2 times 2y is negative 4y, and negative 2 times 10 is negative 20. So then I'm going to write the first equation directly underneath it so that everything's lined up. When I go to eliminate, my x's eliminate and my y's eliminate. So I end up with 0. And then on the right side of the equal sign, I have negative 20 minus 8 more, which gets me to negative 28. So I have this answer of 0 equals negative 28. Ask yourself, does 0 equal negative 28? No, not on this planet, right? So what happened? You're going to say both of the variables eliminated, which is not what you wanted to happen. You only want one to eliminate. So there's no solution. Question B, do these two equations represent the same line? How can you tell? You're going to say no. They are not multiples of each other. They have different solutions. Okay. Part C, if you haven't done so already, write both equations in y equals mx plus b form. How can you explain the solution you got in part A? Okay, so I took the first equation, I subtracted 10x from both sides, I divided everything by 4, and I put it in slope-intercept form. Then I took the second equation, I subtracted 5x from both sides, I divided everything by 2, and I put it in slope-intercept form. When they're both in slope-intercept form, what do you notice about those two equations? You've got y equals negative 5 half x minus y, and y equals negative 5 half x plus 5. What do you notice about those two equations? Dennis? They're going to be parallel. How do you know they're going to be parallel? There's a numeric clue that tells you they're going to be parallel. Does anybody know what it is? Dennis? Their slopes are the same. You have negative 5 half here, and you have negative 5 halves x here. So you're going to say they have the same slope. They're parallel lines. That means they're going to have no points in common. If you graph those two lines, they will never have a point in common. All right, if you're still writing, I'm going to move this up. You'll see it in just a second. There it is. All right, question 104 up at the top says, the equations of two lines are given below. A table of solutions for the first equation has been started for you. All right, so if you have the equation 2y minus 5x equals 8, You take a negative 6 and plug it in for 8, and then you solve for y, you're going to get negative 11. You take a negative 4 and plug it in for x. Solve it for y, you're going to get negative 6. You keep going, you're going to get a negative 1 when you plug in negative 2. If you plug in a 0, you're going to get 4. If you plug in 2, you're going to get 9. And if you plug in 4, you're going to get 14. Okay? Same thing with the second table. If you plug in a negative 6, you're going to get negative 17. If you plug in a negative 4, you're going to get negative 12. If you plug in negative 2, you're going to get negative 7. If you plug in 0, you're going to get negative 2. If you plug in 2, you're going to get 3. And if you plug in 4, you're going to get 8. So the question is, after you've completed the tables for the given equations, can you readily find the point of intersection? Are there any points where the answer is the same? No. So you're going to say no solution. These are parallel lines. Okay? Then they ask you to solve the system algebraically. Was your prediction in part A correct? Okay? So if we plug in the 5/2 x minus 2 into the first equation, and we use substitution here, we're going to need to distribute that 2 here and here. So 2 times 5/2 x is 5x. 2 times negative 2 is negative 4. Then you look for what combines. You've got the 5x minus the 5x, which is 0. So you're left with negative 4. And you end up with this weird answer. You end up with negative 4 equals positive 8. That was like the last page. And you all answered like what? Right? Does negative 4 equal 8? No, it does not. So you say no solution. All right. Question 105 says the equations of two lines are given below. A table of solutions for the first equation has been started for you. So you're going to plug in all the numbers again into the first equation, fill out your table, then you're going to plug in all these numbers for the second equation, fill in your table. Then it says, part A, complete the tables for the given equations. We did that. Okay, using the tables, can you readily find the point of intersection of the two lines? What happens at negative 6? Same answer. What happens at negative 4? You get negative 12. What happens at negative 2? You get negative 7. When you plug in 0, you get negative 2. When you plug in 2, you get 3. When you plug in 4, you get 8. What's happening? All the same answers. You're going to have infinite solutions. If I kept giving you numbers, it would keep happening. Okay? Over and over again. That's called infinite solutions. So graphically, that means it's the same line. So when you graph it over here, you're going to have two lines on top of each other. Can you believe that there are two lines right there? Do you need to really draw it twice? Okay. Part B, graph both lines without algebraically solving the system of the equations. Can you predict how many solutions the system of equations has? We already said that. It has infinite solutions. It's the same line. And then it says when two lines are on top of each other, we say the lines coincide. Say that word, coincide. Coincide. Solve the systems algebraically. What kind of algebraic solution do you get from a system of equation when the two lines coincide? Okay, so we're going to do the same thing we did up at the top. We're going to take this part of the equation, whatever the y is equal to, and we're going to substitute it into the other equation. So we're going to have 10x minus 4, and then instead of writing the y here, we're going to write 5/2 x minus 2 equals 8. You're going to draw your distributing rainbows, and then you're going to distribute. So bring down the 10x. And then negative 4 times 5/2 x is negative 10x. Already, can you see is going to happen? 10x minus 10x is